As we get started today, we'll take a look at your homework in just a moment, but for now, if you would, begin working on the classwork, page 9, doing review 7, 10, 12, 14, and 15. You did 1 through 6 for homework. If you'll do these 5 problems as your classwork, take just a few minutes to work, then we'll go over these answers together. Just a good review of some fraction concepts that we're going to see coming up in a few weeks that we're going to apply to algebra, working the arithmetic fractions now. So good review for you, getting your brain in gear. Good, Abby. Take about another minute and a half or so. Another minute and a half to finish up. Okay, just those 5 problems. Good, Maddie. So Maddie, last year it was the kids in here singing during Bible during our class. Now she's got music playing there. Good, Audrey. All right, for sake of time, put your pencils down even if you're not quite finished with all of them, and let's see how you did on the ones that I assigned. Number 7, we actually looked at a very similar problem yesterday, though it was with exponents, and it was adding fractions 3/4 and 1/2, and we said in order to add fractions, class, you have to have a common denominator. And what is the common denominator between 4 and 2, class? 4. So we're going to leave the 3/4 as is, but we're going to change 1/2 into how many fourths, class? 2. Just multiplying top and bottom by 2. And when we add, we get 5/4. And we don't need to change that to a mixed number. Number 10, we are subtracting. We start with 2 1/4, then subtract 3/6, and then subtract 5/2. Really, the mixed number kind of messes things up a little bit in my mind. So let's change this mixed number into an improper fraction.
You times the 4 times 2 to get 8, and then you add the 1 to get 9/4.
Good, 9/4. And of course, we got 3/6, though we could reduce 3/6, class. 1/2. And then negative 5/2. Now, there's a shortcut and there's a long cut. Here's my shortcut. I'm subtracting 1/2, and then I'm subtracting 5 more halves, right? How many halves am I subtracting? 6 halves. But subtracting 6 halves is the same thing as subtracting 3. So I could change this to 9/4 minus 3, which top and bottom times 4 gives me 9/4 minus 12/4 equals negative 3/4. I think that's a little quicker, but the other option, of course, would be just to change everything into fourths. And so you could say I've got 9/4 minus class 2/4 minus another 10/4. And you still get negative 3/4. Okay, how many had negative 3/4 on this one here? All right, questions on that one. Does it make sense now if we did not get it? Any questions? Say, I'm still confused. All right. Number 12. We had a multiplication problem. 27 halves times 12 ninths. Remember, with multiplication, you get to cancel stuff. Numerators get to cancel with denominators. What's something we see that can cancel here, Michael?
27 and 9.
Let's cancel 27 and 9 to get
3 and 1.
3 and 1. Something else we can cancel, Kendall?
2 and 12.
2 and 12 to get?
1 and 6.
So when we multiply, we just get?
18.
18. Now, could you multiply without canceling? Yeah, but I can't do 27 times 12 in my head. I mean, 2 times 9 I can do. I can get the denominator of 18. But to get 324 just like that is going to be a challenge. So, yeah, rather than multiply, cancel, reduce it down. How many did get 18 for number 12? Good, several of you questions on that one. All right, let's see, number 14. We got mixed numbers again. We don't work with mixed numbers in algebra class. We need to change the 6 2/3 Genesis into 20 thirds. And Audrey, we can change 4 5/6 into 29 6. Not much to cancel, unfortunately, here, Noah. There's just a little bit.
2. Take 2 20.
Good. Don't fall into the trap of trying to cancel here. Remember, side to side can't cancel. It's numerator with denominator, and there's a 2 that comes out of each to get 10 and 3. And remember, we don't need mixed numbers. Improper fractions are great. Fortunately, 29 times 10 I can do in my head, so can he. Over 9. And there's our answer. How many got 290 ninths? Hopefully you didn't make it an improper or a mixed number. That's such a waste of time. Questions on this? All right, last one for the classwork was number 15. Again, we want to change 4 1/3 into, and 5 2/3, both of these into improper fractions. Abby, 4 1/3 becomes?
13 and 3.
13 thirds. And 5 2/3 becomes what, Maddie? 17 thirds, but it says I'm supposed to divide 17 thirds. Do we ever divide fractions, class?
No.
We always multiply by the reciprocal. So I'm going to change this to multiply, not by 17 thirds, but by the reciprocal 3/17. Conveniently, class, we can cancel the 3, and it leaves me with an answer of 13/17. Those who made it that far, how many got this answer on 15? How many got all the ones you did correct? And we get all the, even if you didn't do them all the ones you did, you got right. How many maybe just missed one of the ones you did? Just missed one? All right, do we understand the one that you missed? Anyone that missed more than one, have a question, want to see something worked out? Do we want to see any of these reworked or a similar problem worked? And we want to see a similar problem worked. Again, we'll be doing this with algebra stuff soon, so I want to make sure we remember how to work fractions. Any questions? All right, let's take a look at 1 through 6 then, which you had for homework. So have your homework out. Find where you did the 1 through 6. And that's where we're going to start. I don't even know that it was the first thing I told you to do, but it's where we're going to start today. Practicing with order of operations. Of course, the first thing in order of operations class is? Parentheses, or more generally, grouping symbols. Second thing? Exponents. Third? Multiply, divide, left to right, however they come. And then fourth? Add, subtract, left to right, however they come. Number 1, what'd you get for your answer, Maddie? 13. Number 2, Abby?
-27.
-27. Number 3, Kendall?
62 and a half.
Not 62 and a half.
67 and a half.
67 and a half, or you might have had, hold on, 135 halves, okay? Could have been an answer as well, or 67.5. Any of those answers would be acceptable. Number 4 for redemption, Kendall.
103.
Ooh, you did.
-329.
Oh my,
113.
so close. Anybody?
I got -111.
Should be -113. We're definitely going to take a look at this one. -113 should be our answer. All right, let's go to number 5. Third try's the charm. Kendall?
40 and a half.
Oh, third try was not the charm. Noah?
43.
Oh, 44 is the correct answer. All right, Noah, third try's the charm. What'd you get for number 22? For number 6? Nope. Kendall?
96.
No!
-22.
-22. There was a 22 in there, which is why I slipped up and said that. But -22 is the answer. Nice guess, though, Noah. All right, so I think 4, 5, and 6 all need to look for sure. Does anyone need to see 1, 2, or 3? Anyone need to see 1, 2, or 3? I guess, Kendall, you had some trouble with 3. Do you want to go over number 3? No. Did you find your mistake? Okay, let's take a look at 4, 5, and 6. The key here, I think, is the negatives, right? Now it's just a little problem. I'm going to go ahead and put the negative 3 in parentheses, just so I don't lose sight of that negative. It's a plus 4 times the negative 3 cubed. And be careful here. What is being cubed, class?
Negative 3.
Only the negative 3, not the 4. But the negative is being cubed with the 3. So it's negative 3 times negative 3 times negative 3 would give me, class,
Negative 27.
negative 27. Not just 27, negative 27. So we got a 15 divided by negative 3 plus 4 times negative 27. I've got a division, an addition, and a multiplication. Two things I can do at the same time, class.
Multiplication and division.
Divide and multiply. When I divide here, I should get negative 5. When I multiply here, I should get negative 108. Add those to get negative 113. Now, if you lost a negative here, that might have given you a negative 103. So maybe that's what happened. Questions on number 4. Did we all find our mistake? Or is there someone who's like, I don't know what I did? Or anyone who says, I don't know what you just did. Any questions on this? All right, parents are that way sometimes. Like, what did you just do? I don't even know. All right, I remember that one. Number 5, we had 8 times 7 halves plus 4 squared. First thing we need to do in this particular problem, Kendall?
Divide.
Not yet. There's something before division.
Multiply.
Multiplication, right? Or, nope, not multiplication.
Exponent.
Exponent, sorry. Exponent. 4 squared gives me,
16.
I was asking Kendall, but yes, 16. I didn't say her, I didn't say her name this time. She's the one I was talking to. Now we can do some multiplication here, Kendall. If we'll put this as 8 over 1, it'll help us to see the multiplication. Because in this multiplication, I can cancel the
8 and the 2.
to get,
1 and 4.
which gives me
28.
when I multiply to get 44 for the answer, right? So those who had missed number 5, do we understand it now? Any questions still on that one? All right, and then number 6, we have 12 minus 6 times quantity 6 plus 3 over 3 minus 4 squared. Do I really need those parentheses? Absolutely not. The fraction bar already groups it all together, but we'll roll with it anyway. In the parentheses, start with the numerator, 6 plus 3 class, 9. And then the fraction bar tells me to divide 9 divided by 3. 3. So it becomes 12 minus 6 times 3 minus 4 squared. Let's now take care of Noah the to get 16. And you know what? This multiplication right here is detached from the other stuff anyway, I suppose. The 6 times 3 is class 18. So we've got a positive 12 minus an 18 minus a 16. We just take it in order. This gives us a negative 6 plus the negative 16 gives us the negative 22. Or you could, the way I like to do it, combine the two negatives to get negative 34 and add a negative 34 to the positive 12 to get the negative 22. Your call there. Questions on number 6? Anyone happen to get all 6 correct? I don't think anyone was 6 for 6. How many 5 for 6 just missed 1? Okay, a couple of you. 4 for 6 just missed 2. All right, so the 1 or 2 that we missed, we understand now. Or 3 or 4 or 5 that we missed. All right, questions on this. We understand it now. All right, look back, across the page, page 8. And we were practicing with laws of exponents yesterday. And we said that when we raise a power to a power class, we multiply we multiply the exponents. Let's try it again. When you raise a power to a power class, you multiply the exponents. When you multiply like bases, class, add the exponents. Let's try that again so it's a little stronger. When you multiply like bases, class, you add the exponents. When you divide like bases, subtract the exponents. A negative exponent means what, Maddie? No, what does a negative exponent mean? Noah laughed, so he must know. Reciprocal. You did know. Good job. I wasn't really surprised. I was confident, Noah. I just have a very surprised voice. Yeah, reciprocal. Negative exponent means reciprocal. 0 power. Anything with a 0 power, Michael, is 1. So some laws there that we practiced with. We were especially, though, looking at the negative exponents primarily here. Number 43, you were supposed to simplify a to the negative second. What did you get, Brandon?
I got 1 over a squared.
1 over a squared. Number 45, we had a d cubed f to the negative second. Genesis?
1 over d cubed f squared.
Well, there is a negative exponent on the f, right? So the f has got to move down, but should the d go anywhere? No. So technically, Genesis, as written, it's technically over 1. It just doesn't show it. So since the d doesn't move, but the f does move, we should leave the d cubed and have d cubed over the f squared. Does that make sense? All right. Number 47, we've got a whole bunch of stuff moving, and there's a little bit of division we need to take care of. Audrey, what was your answer?
3b cubed y to the 6th over x squared y to the 9th.
Well, that's a w to the 9th, so yeah, but otherwise good. And then we, of course, alphabetically, we put the w first. So yeah, we have a 3v cubed y to the 6th over w to the 9th x squared. Number 49, this time we've got some stuff to move around, and then we're going to have to multiply like basis by adding exponents, and there's a little bit of reducing of the numerical coefficient, which is a fraction. I need somebody really smart for number 49. Brecken. No, Brecken can't answer. Abby, help Brecken.
2u over 17.
Yeah. 2u over, oh, I see what you did. Brecken's like, no, Abby, no. I can hear Brecken. He's actually saying it's 2u to the 7th over 17w to the 4th, and that is correct.
Oh.
Good job there, Brecken. Let's take a look at 49, because I bet some of you here, not Brecken, not Gavin, but some of you in here, did what Abby did. The 4/34, because you're smart, you reduced to 2/17, which is good. And then you had a u to the 4th and a u to the -3rd, and Abby's like, oh, the 4 and the 3 cancel to give me 1, but it's not a 3.
Yeah, move it up.
You have to move it up where it becomes a u cubed, and now we're multiplying, and that's where Brecken got the u to the 7th. Similarly, a w to the -2nd doesn't cancel with a w squared. It moves down and becomes another w squared together, and that's where Brecken got the w to the 4th. Do y'all see what he did now? Okay, any questions on that? How many did get the same answer as Brecken? Okay, good job, gentlemen. It just guys swept it, other than Noah. Gavin even got it. Good, Gavin. All right. You feel bad now, Noah? All right. Were there questions on 47, the answer that Audrey gave us a moment ago? Anyone need to see 47 worked out before we move on? Going once. Going twice. All right, let's move on then. Now we're getting rid of denominators. So if it's in the denominator, it's got to move up. And we use negative exponents to move stuff up. 51, what was your answer, Maddie? To the -3rd. There we go. Yeah, so cube is specifically a positive 3 exponent. C to the -3rd. How about number 53, Kendall?
4x to the 5th, y to the -7th, z to the -2nd.
Great job. 4x to the 5th, y to the -7th, z to the -2nd. And number 55, Michael.
4x cubed y cubed.
You fell into an Abby trap, and you cancel the v to the -2nd and the v squared with each other. We actually have to move this up as another v to the -2nd, and that combines to give us a v to the -4th. So otherwise the answer was correct. So 4v to the -4th, x cubed, y cubed would have been our answer. Let's see, there were 1, 2, 3, 4, 5, 6, 7 of those. Anyone go 7 for 7 on those? Great job, Brandon. 6 for 7. Oh, Brecken too, good. Okay, 6 for 7. 6 for 7. Okay, Gavin, good, and several of you. 5 for 7, just missed a couple. Are there questions on the one or ones you missed? Any of them you need to see worked out? All right, turn over to page 16 now. Page 16. Let's finish looking at the homework. And you have the 11 through 23 odd, simplifying again, practicing with those exponent properties, things of that nature. Number 11, your answer, Abby.
9x to the 8th.
Good, 9x to the 8th power, because when you raise a power to a power class, you multiply the exponents. Number 13, Noah. D is correct. The c cubes cancel because we subtract the exponents and then subtract the exponents again and get d to the 1st in the numerator. Number 15, what'd you get for your answer, Audrey?
16mn to the 4th over kr cubed.
Great job. 16 mn to the 4th kr cubed. Number 17. We got a bunch of worthless stuff in there. What did you get for your answer, Brandon?
an over m to the 7th.
an over m to the 7th. How many just kind of scribbled out all the 0 power stuff that was in there? Like, why? It doesn't exist. Anyway, girlfriend to the 0 power. I feel you now. All right, number 19. You shouldn't laugh, Brandon. All right, number 19. I'm just mean. Brecken's like, I'm so glad I'm not in that class anymore. We haven't forgotten about you, Brecken. All right, number 19. Practicing with some negative exponents here, and let's go to Michael.
C cubed in m cubed r squared.
Do you have a fraction bar on that answer somewhere?
Yes, over m cubed r squared.
Oh, okay, c cubed and over m cubed r squared. It's like, I bet he has it right and forgot to mention the old fraction bar. Okay, does make a difference. Good, and number 21, moving around some stuff there, Genesis.
d to the second, h to the seventh, k to the negative 6.
Well, it said no negative exponents, so we don't want to keep that k to the negative 6th. We want to move it down where it will become k to the 6th. We'll have, of course, the h to the 7th, as you said there, because the 9 minus 2 gives you the 7. Now, here we've got a d to the 4th and a d to the negative 2nd. So, Genesis, we've got to move the d to the negative 2nd up where it will become, d squared. And now I need to multiply these together to get, when you multiply like bases, add the exponents. So, there we go, d to the 6th, h to the 7th over k to the 6th should have been our answer for 21. And number 23, your answer, Audrey.
H to the 7th, x squared, y to the 11th, over w to the 14th squared.
No. Kendall, help friend.
H to the 11th, w to the 14th, x squared, y.
You wouldn't happen to have that in a denominator, would you? Like 1 over all of that? You should. Should be 1 over h to the 11th, w to the 14th, x squared, y. Let's take a look at this one as well. The h to the negative 9th, of course, is going to have to move down to become h to the 9th. I'm not even going to write the w to the 0. I got the w to the 14th. The x to the negative 2nd has to move down to become x squared. The y to the 11th stays up. The y to the 12th is here. So the h to the 9th is slid down. There was already an h squared here as well. So these two h's, that's where she got the h to the 11th, and technically all underneath what's going to be a 1 here. W to the 14th has no friends. Don't laugh, Brent. Squared moves down. And then here we can cancel these 11 y's with 11 of these 12 to leave us with just 1 more. And so that was the right answer. Just, again, with all the moving parts, I think just forgot to put the 1. But I think the algebra process itself was a good job there. Did anyone get all 7 of these correct? 7 for 7. Okay, Brandon, you can laugh. All right, good Brandon, good Abby. Anyone 6 for 7? Just missed 1 of them? Okay, good. We understand the one that we missed. All right, miss a couple of them, and we understand them. Any that we need to go over we didn't already cover. All right, turn back to page 6. Turn back to page numero 6. And some algebraic representation stuff I want to review from really the last couple of years. You worked on this a little bit, I think, in junior high, but a lot more last year in Algebra 1, or for some of you a couple of years ago in Algebra 1. Different ways to show different things. For instance, addition. Obviously, we use a plus sign. But we can use different words to express it. For instance, that expression, 3 plus 7, could be said 3 increased by 7. It could say the sum of 3 and 7. You could say 7 more than 3, right? Some different things you could say there. For the subtraction, of course, we could just say 3 minus 7, but 3 decreased by 7 means the same thing as you're looking there on page 6. The difference between 3 and 7. You could say 7 less than 3. You could say 3 less 7. You could say, if 7 is subtracted from 3. There's all kinds of ways you could express that. Obviously, 3 times 7, scribble out that first one they've got there for a symbol. We don't use that multiplication symbol anymore. Shame on them. We use a raised dot or parentheses. Now, if they're letters, we run them together. We don't run 3 and 7 together because that would look like 37. That's no good, right? But 3 times 7, the product of 3 and 7, thrice 7. Whoa. All right, division. 3 divided by 7. The quotient of 3 and 7. Might say the ratio of 3 and 7. 3/7. All right? An expression of equality. A lot of times verbs like the word is or perhaps was in the past tense, or it gives or produces or results in, something like that. But 3 plus 7 equals 10. The sum of 3 and 7 is 10. 3 and 7 added together gives 10. 3 increased by 7 yields 10, something weird like that. But then there's some inequality statements as well that you'll recall from last year, Algebra 1, or 2 years ago, Algebra 1. Less than or equal to could also be read is no larger than or is at most. Of course, less than, Doesn't equal, is not equal to, is different from, is greater than, or perhaps for the greater than or equal to, you could say is no less than or is at least. All of this should be review as I was reading over, as you were skimming it while I was reading. All of this should be review, but are there any questions before we progress? All right, look at the examples then. Notice how they translated these different word phrases into algebra. Read number 1 for us if you would, Maddie. The difference, of course, is the answer to a subtraction problem. So now we're subtracting. It says difference between 10 and 6. Take it in the order given, 10 minus 6. There is a word, though, that tells us to flip the order. From past years, what word tells us to flip the order in a subtraction problem? Write this in the margin of your book. The word than, T-H-A-N, means to flip the order. So, for instance, if it had said 10 less than 6, we would flip-flop and we put the 6 first, then minus the 10. Okay, so if you see the word than, it means flip the order. Look at number 2. Go and read number 2 for us. Genesis.
The sum of x and y is 20.
The sum, so we're going to add some things, of x and y. Okay, that's what I'm adding. So x plus y equals 20. So you see x plus y equals 20. Number 3, read that for us if you would, Brandon.
Q is at least 16.
At least 16. So for instance, maybe we're talking about one of you. And I say, I may not know how old Genesis is, but I know she's at least 16. Does that mean she's 16? Maybe. But she could also be 17. She could be 18. She could be 25. She could be 84. And she just looks really good for her age. We don't, actually we do know because we have records in the office. But anyway, we wouldn't let an 84-year-old into a 10th grade or an 11th grade class, sorry. But at least just means that old or older, that old or more, that or greater than or equal to, so hence Q is greater than or equal to 16. Read number 4 for us, if you would, Noah.
The product of x and y increased by 9.
The product, which means we're going to multiply some things, of x and y, okay, that's what I'm multiplying, x, y, I don't like the raised out, I'm too lazy, increased by, okay, that means I'm now going to add to the xy 9, so xy plus 9. Do we remember doing this in years past? Any questions on translating words into algebra? Maddie looks bored. She's like, let's just go, come on. This is so easy, Mr. Nadasky. I'm disgusted with this right now. Okay, let's go, Maddie. All right, turn to page number 8. Turn to page 8. I want you to do 57 to 69, the odd. 57 to 69, the odd. You might be able to work those or write the answers right there in your textbook. If you want to write small, like Audrey. Not small like Audrey, but writing small like Audrey. Kendall's like, yes, he got somebody else for a change. No, that wasn't what I was saying. No one is taller than you now, just saying. I just like, thank you, I needed that. Brett can be like, I'm glad my little sister's not taller than me. Love it. It's going to be really hard when Peter becomes taller than you. That's probably where it's going to really hurt. Good, Abby? Genesis, Maddie, Noah, Michael. Alright, looks like we're about finished up here. Good. Let's see who's going to be last. I'm just like, I have an excuse. You were picking on me the whole time. It's okay, I won't do that during tests, I promise. I'll only pick on you briefly. We're just doing the odds. I was like, I see her, I just suddenly dawned me where the problem is. Her pencil's over there on the even column. Just the odds. All right, so Well, she's going to be the first one done with the evens, I can tell. All right, let's take a look at these. How would we write 7/9? 7/9. How many got that one? Good. It's insulting, isn't it? 59. X is less than 0. Should have X less than symbol 0. That's what it said. The quotient of 3 and 4, Audrey. 3 divided by 4. How do we show that? 3/4. That's a fraction bar, right? So 3 over 4, 3/4. The difference between 1 and 9, Genesis. 1 minus 9. Good. There's nothing in there to indicate flipping the order, so we should have 1 minus 9, not 9 minus 1. Number 65. B is less than or equal to 2. B is less than or equal to 2. Just literally write out exactly what it said. 2 increased by 5, Brandon.
5 plus 2.
Well, again, there's nothing in there to indicate a flipped order, so 2 plus 5 is preferred. But as we talked about commutative property, it doesn't matter. Technically, you're correct. But 2 plus 5 is preferred. How about A is no less than 3, Michael?
Yeah, I did the 67.
Oh, all right. How about 69, Noah?
A is greater than or equal to 3.
Good. If it's not less than, then it must be either greater than or it could be equal to. So A is greater than or equal to 3. How many got all of those correct on that column? All right. Questions on the ones we may have missed or forgotten to do. All right. Do the next column, 58 to 70. Oh, good. Audrey's finished. 58 to 70, the even now. Now she's finished. All right. What's wrong with the rest of you? Come on, let's go. What, Audrey, since you're done so quickly, and Noah, why don't you take a look at 73 to see if you can remember how to do those. You should be able to. Good, Genesis. Maybe tackle 73 while you wait for the others. Ditto, Abby. All right, let's take a look at the evens together. Number 58, how would I show X is different from 8? Maddie? Well, it didn't say X was bigger. Different from could mean like 2 is different from, right? Abby?
X is not equal to 8.
X is not equal to, so we use the equal sign with the slash there. X does not equal 8. Back to Maddie for redemption. Number 60, the sum of 8 and 3. 8 plus 3. Number 62, y is greater than or equal to 0. Y is greater than or equal to 0. How about 64? D is no larger than 7. Kendall?
D is less than 7.
Well, by not being larger than, it could be the same, right? That still wouldn't be larger than. So not D is less than 7, but D is less than or equal to 7. Good. D is less than or equal to 7. For number 66, 4 minus 10. Some of these are just serious. Let's see. Y is greater than 6. Y is greater than 6. The product of W and Z. Genesis? WZ. All right, good to go on those? All right, any questions at all? Flip back to page 7. One of the last really fundamental algebra concepts I want to review over is evaluation. Evaluation is basically put a number where a letter used to be, and then use order of operations to finish simplifying it. Look at the expression they give you in the example problem at the top of the page. W cubed minus 4W times W plus 2, that quantity. Well, W can be anything. But you understand the value of the expression changes as the value of w changes. For instance, if w equals, I think it's -3 is the first one. If w equals -3, then everywhere I see a w, I'm going to start by just plugging in a -3. What this means is that on a quiz or test, if you had an evaluation problem, and you showed this step, I would give you partial credit, because that's the first step. Just plug in the -3 everywhere you see a w. Now the next step would be follow order of operations. Do what we've been doing for the past little bit. Let me get the poster in the screen here. Do what we've been doing. So as far as order of operations, what's the first thing I need to do here, Abby?
Exponents, the parentheses.
Parentheses. I've got parentheses right here, -3, +2, of course, using our signed number rule gives us.
What?
We have a -3 plus a +2. What do we get?
-1.
-1. Good. Subtracting the sign of the greater. And then, of course, we have this -3 and -4 and -3 cubed. All right, the next thing, order of operations, we need to do here, Audrey. Now we'll take care of the exponent. And again, we actually saw the -3 cubed in our homework, but -3 when you cube it gives? -27. So we have -27 minus 4 times -3 times -1. Technically, a couple ways you could view this, just as a quick refresher for you from your Algebra 1 days. You could think of this as a minus, in which case it's these three things being multiplied. What is 4 times -3 times -1, class?
12.
+12. Because there are two negatives, you multiply to get +12, in which case you would say -27 minus a +12. But we never really subtract in algebra class, we add the inverse, and that gives us -39. The other option is to look at this and say this is a -4 being multiplied by a -3 being multiplied by a -1, in which case I have 1, 2, 3 negatives. Well, 3 negatives comes out negative, which gives me -27, and this all becomes a -12, which still gives me -39. Okay, so a couple ways to look at that. Questions on evaluation and then following order of operations. Any questions on signed numbers while we're at it as well? Any questions on that? All right, it kind of assumes you know your signed numbers by the time you get to Algebra 2. Look at the next example. Well, what if instead of w being -3, what if w is instead 2s? Well, you realize you're replacing a variable with a variable value, right? So I'm not going to get something nice, easy, and straightforward, am I? For one thing, can I combine 2s plus 2, class?
No.
They're not like terms. You can't add those together. So you just have to leave it 2s plus 2. You can cube the 2s here, Michael, to get?
8s.
We did a good job of cubing the 2, also cube the s.
Yeah, 8s cubed.
8s cubed. We can multiply these two monomials together to get, Kendall? -8s. But that -8s has to be multiplied by the binomial quantity, and we have to apply which property now, class? Anyone? Distributive property, because we're going to have to distribute the -8s. So we'll keep, I'll move it up here, the 8s cubed. What do we get when we distribute -8s to 2s positive 2? Genesis? Sign, number, letter? Squared. All right, and then we'll also distribute here the positive 2, sign, number, letter? Negative times positive?
Negative.
I'm blocking your view apparently with the lecture. Go ahead.
-16 s cubed squared.
There's no other friends. It has no friends, just an s. And there we go. So a little refresher there on some distribution. Questions on this. Notice my answer doesn't come out to a number this time. It comes out to an expression because it's still not a variable quantity. With fractions, we'll look at it for sake of time. You could cube the 1/2. Remember, cube the top, cube the bottom, get 1/8. You could actually combine 1/2 and 2 to get 2.5 or 5/2. You could multiply the -4 times the 1/2 to get -2, which 2 over 1, cancel the 2's, gives -5. And you can subtract the 5 from the 1/8 to get -4 and 7/8, or make it a -48 with a positive 1/8 to get -39/8. Questions on evaluation? Do we remember doing this in years past? Turn over to page 8. Let's look at 73. We're given the expression y cubed times 2 minus 1. By the way, this is not the best way to write the expression. Volunteer, what's the best way to write that expression?
2y cubed minus 1.
Yeah, I don't like the raised dot. Numbers should come first anyway. 2y cubed minus 1. So this is really what I'm going to work with. And they say, well, what if y is 4? 3 steps. First class, we need to
Exponents.
cube the y. Then we need to
Multiply by 2.
multiply by 2 and then
Minus 1.
subtract 1. Can you do it in your head? Or maybe on paper. Plug in the 4. Cube it, multiply by 2, subtract 1. And we get, anyone?
127.
Good job, Michael. 127. 64 times 2 is 128 minus 1 is 127. What if we know that y is negative 3? Follow the same steps. Call it when you've got it.
Negative 55.
2 for 2, negative 55. Cube to get negative 27 times 2 is negative 54. Negative 1 is negative 55. Look at number 74. Got a couple binomials. Y plus 2, y plus 3. We could FOIL them, I guess. We don't want to, though, because we know that y is simply equal to 1. Plug it in your head. What do we get?
7.
You're multiplying them.
12.
12. There we go. Sister beat you. What if y is... what if y is negative 1? 2. Brandon, good job. Okay, we remember evaluation, plug it in. Do 71 and 72 at your seats. 71 and 72. I'm going to do these 2 problems, then we'll be done for today. Maybe do the x equals 1 for the last. I'm lazy. I gotta do the hard part last. Right on that one, wrong on that one. Oh, that's For sake of time, check your answers. Of the ones you got done, even if you didn't get them all done. I went 3 for 4. I missed this one. My brain cubed a 2 to get 8 instead of squaring a 3 to get 9. I don't know. I'm human. 24 should have been our answer there. For this one, negative 4 and 7/8 if you decided to tackle the fraction, or negative 39/8. It's negative 61 for n is 2, and 51 for n is negative 2. How many got all the ones you did right? You did better than I did. All the ones you did, you got right. Good job, Kendall. Genesis show-offs. How many missed one like me? Missed one of the ones you did? All right. Anyone miss all the ones you did? Good, good. Okay. You'll practice a little bit with this in the homework. Homework is to do. Page 16. Page 16. 1 through 10 all. 12 through 24 even. Page 16. 1 through 10 all. 12 through 24 even. We'll take a look at that homework in our next lesson. All right, have a wonderful rest of your day, and you are dismissed.